Hello, welcome to my channel. We will be doing question number 10, chapter 1, mechanics. Okay, this is an interesting question, a bit challenging. So the scenario is that we have a road, a highway, single lane in each direction. Okay, so this is the road. So I can draw the straight lines, correct? Okay, so there's a tractor going in front of a small car, right? And both of them are traveling at the speed of 15 meter per second. Okay, 15 meter per second, both of them. Okay, the speed limit posted is 25 meters per second. Okay, so the car decided to overtake this tractor. Okay, the safe distance between them is 20 meter. So when the car was 20 meter behind, it decided to overtake. In order to overtake, the car moves to the next lane and then accelerate. Okay, and it accelerates to what's the acceleration? 2 meter per second square. Okay, so for the car, initial speed is 15 meter per second, and it accelerates with an acceleration of what did I say? 2 meter per second square, right? Okay, it accelerates until it reaches the speed limit, and then it stays constant. The speed remains constant. So I want like to see that how long it will it was accelerating. So we know that the final speed of this car is 25 because this is the speed limit, meter per second. So let's quickly calculate the time it will take. So time is Vf minus Vi over A. Remember the famous equation Vf equal to Vi plus At? So I just rearrange that equation. Okay, so Vf is 25, Vi is 15 over acceleration is 2. So 25 minus 15 is 10, 10 over 2 is 5. So it's 5 seconds. Okay, it means if we look at the uh, velocity time curve for the car, so it started with a speed of 15 and accelerates for 5 seconds, and its speed become 25, and then it was moving with a constant speed of 25 meters per second. Okay, so this is the speed time curve of the car. Now, how much distance it has traveled? Okay, so distance traveled by the car, it is VIT plus half AT square. This is for the first 5 seconds. Okay, so velocity was 15 meter per second, time is t, and half, and a is 2, and t squared. So this is t squared. So this is going to be 15t plus t squared, and this is valid when t is from 0 to 5 seconds, right? Okay, so what is the, okay, and how much is the distance traveled by the car after 5 seconds? Okay, see how much cars have traveled in 5 seconds. So this is 15 times 5 plus 5 square. So this 75 plus 25. This is 100 meter. Okay, so the car has traveled in the first 5 seconds. The car has traveled 100 meter. Now, what is the position of the tractor after 5 seconds? Okay, remember it was 20 meter ahead of the car already. Okay, plus uh, now its speed is 15 meter per second or 15 t, right? So this is, sorry, this is a function of time. So if I want to calculate the distance traveled by the tractor in 5 seconds, so what I will do, 20 plus 15 times 5. So this is 75 plus 20 is 95. Okay, meter. So you can see that after 5 seconds, the car has traveled a distance of 100 meter and the tractor has traveled a distance of 95 meter. So car is 5 meters ahead of the tractor, but this is not a safe distance to come back to the its own lane. The safe distance is 20 meter, right? Okay, so first, okay, now I want to calculate, let's say, the gap between the two things. Okay, the two vehicles. So gap between the two vehicles, I will write it as distance traveled by the car as a function of time minus distance traveled by the tractor as a function of time. Okay, distance traveled by car is given by this expression 15t plus t square, right? This is the distance traveled by the car minus distance traveled by the tractor, and that is 20 plus 15t. So if I rearrange this thing, it is 15t plus t square minus 20 and minus 15t. So you can see 15t cancelled with minus 15t, and I have only t squared minus 20. So many meters. This is how the distance is between the two things, two vehicles. You see, this is what we have to prove, that the spacing is t square minus 20 for the first 5 seconds. Okay, so to overtake the car, goes onto the other side of the road and accelerates until it's when it continues to speed. Show that the distance the car is ahead of the tractor at time t after the start accelerating with this and reduce that the car is not a safe distance ahead. Okay, and so we are done, right? This was part A. So let's do part B now. Let me change the color. It looks more nice. Okay, so part B I'm doing now. Part B says the car pulls in ahead of the tractor once it is at a safe distance. Okay, find the total time taken from the start of the overtaking maneuver until the car has safely overtaken the tractor. Okay, now I want to find out that okay, if you find that total time, yeah, total time you need to find out. Okay, so I would like to express the distance as a function of time for the car. Right? We know the distance of the car for the first 5 seconds given by this expression, right? But what happened after that? Okay, so the distance traveled by the car as a function of time, we know that at the end of 5 seconds, it has traveled a distance of 100 meters, right? So 100 plus. Now it's going to be the constant speed. And the speed is 25 because it's on the speed limit. So 25. And the time is t minus 5 because we are talking about the next 5 seconds, right? Let me confirm with my solution. Uh, yes. Okay. So this is when t time is more than 5 seconds. So I can write this expression that distance covered by that car as a function of time. It is given by 15t plus t square. This is when time was between 0 and 5 seconds. And it is 100 plus 25 and t minus 5 when the time is more than 5 seconds. Okay. And what about the distance traveled by the tractor as a function of time? Look at it, tractor is going with a constant speed, no acceleration, so this is easy. And we have found it before as well. It is 15t because its speed is 15, time is t, and it's already 20 meter ahead. So I will say this is 20 plus 15t. This is for all the time. Okay. So, um, yes. Now, this gap, right? The gap between the tractor and car, it is going to be Uh, since I'm talking about 5 minute off, 5 second off later, so it is 100 plus, and I will open this thing 25t minus 25 times 5 is 125. So this is the distance traveled by the car minus distance traveled by the tractor, and that is 20 plus 15t, right? So when this gap is equal to 20 meter, that's the time when it will overtake. We come back to its own lane, right? So if I solve this equation, I can find the value of t from here. Makes sense? Okay, so if I open this, it is 100 plus 25t. Okay, 100 minus 125 is minus, sorry. So 100 minus 125 is minus 25 plus 25t minus 20 and minus 15t equals 0. So 25t minus 15t is 10t, and this is minus 25 and minus 20 minus 45. It goes on the other side, become 45. Am I doing it right? Uh, Something is wrong. 20 plus 45. What did I do? What mistake I did I make? Minus 20. So I did something. Error one here. Minus 20 minus 15. Yes. Okay, so this is okay, sorry. This is 20. Yes, yes, yes. Okay, I'm sorry. So I have 20, 45 plus 20 here, right? Yeah, my mistake. Okay, so this is total 65. So t is equal to 65 over 10. So it is 6.5 second. Okay, so 6.5 second after it started the maneuver, the car will be able to come back to its own lane. Okay, the car pulls ahead of the tractor once it is in safe distance. Find the total time. So the time is this one. This is the answer for the part B. Okay, they take it from the start of the maneuver until say, okay, very good. Now part C. Okay, in order to do part C, I need some room, so I will erase a big chunk here. Yes. Okay. Um, okay. Now I'm doing part C. Okay. To overtake safely on the single lane road when the car returns to the correct side of the road in front of the tractor, there must be a gap between the car and the oncoming traffic of at least 20 meters. Assuming a car traveling in the opposite direction is moving at the speed limit, find the maximum distance. For the minimum distance, it must be from the initial position of the overtaking car. Okay, so assuming there was a car in the opposite direction coming in this way, right? And we have to see that how much should be the safe distance of this car before it starts maneuvering. Okay, so we realize that 6.5 seconds it takes for him to come in this lane and go back over here, right? So in this time, the distance traveled by the other car, okay? So the distance traveled by the car coming in the opposite direction, this is going to be 25 is the speed and time is 6.5. So that would be, let me calculate. 6. Yes. 25 times 6.5. So it is 162. 162.5 meter. Okay. So this is the distance that this car will travel while it is overtaking. Okay. Now the safe distance is 20 meter. So it should be 20 meter before beyond this one. So that distance is 162.5 plus 20. That is 182.5 meter. Okay. Now in the same time, 6.5 meter, this car which was overtaking, it has traveled some distance as well. Right? So how much distance this car has traveled? Okay, so the distance traveled by our car uh, in 6.5 meter, 6.5 second. Okay, I will use I use this thing. No, I'm sorry. I will use this formula, right, to calculate the distance. Okay, so it is 100. Uh, yes. Okay, this is 100 plus 25 and time is 6.5 minus 5. So this would be 100 plus 25, 6.5. Yes, 137.5. Okay, so the total distance total is the distance traveled by our car, which is 137.5 meter, plus in the same amount of time the distance traveled by this car, which was 162.5 meter, and plus a safe gap of 20 meter. Okay, 157, yeah, of 20 meter. So if I add all these three quantities, plus 137.5 plus 20, it comes out to be 320 meter. Okay, so I hope you understand the whole scenario that if this car comes in opposite direction, when our car decides to overtake, this distance should be 320 meter minimum. Okay, then we will be safely come here, accelerate, then overtake this car and come back to our lane, and the minimum distance was still 20 meter. Okay, so it was interesting question. I hope you enjoyed it. If you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.